Hi everyone, welcome back to this third part of the tutorial series on making a multiplayer game in Godot with Firebase. Last episode, we started with the synchronization of remote players by listening for events from the Firebase server. In this video, we will continue on that path and get the other players spawned and moving in our local game. Let's get started. At the end of the last episode, we had the server sent events parsed and ready to be used to spawn and update the players. So let's define a function to do just that, which we can call for each of our events. All the events always contain two fields, a path field and a data field. There are two cases we need to handle. We can either receive all players at once or single player updates individually. If we receive all players at once, the event will have a path with only the root slash in it and a list of player data. If we receive a single player, the path will contain the player ID in it and the data will be for that single player only. Let's first handle the case where a list of players is sent. If the data is not empty, we iterate over all player IDs in the data of the event and create or update that player. To store these players, we can create a dictionary with the player ID as a key for easy accessing and its player data as value. We then also need to check if any player is not connected anymore, and in that case we can remove it from our dictionary. For the second case, we need to get the player ID from the path by splitting the string at the slash and getting the last element by specifying the index -1. We then check if the data is empty, and in that case we need to delete the player. Otherwise we can simply update the player as well. Now we can check if everything is working by printing out how many connected players we have. If we run 2 instances, we should see the number of connected players to be printed out as 2. We now disconnect with one of the players. You should see the connected players change to 1. You can also verify that this works with more than 2 players. So you can go to debug, run multiple instances, and select run 4 instances. Now you can see that 4 players are connected, and if we close the windows, one by one they will disconnect. We're almost there. We now just need to spawn a new node when a player connects and update its position whenever we receive an update from the server. To spawn these players, we want to create a separate scene that we can reference as a packed scene and instantiate whenever we need to create a new player. So let's duplicate our local player node, remove the local player script and add a new remote player script to it. Then save this node as a scene in the project files. Now we can remove it from the scene tree, as we will instantiate it dynamically in our sync code. In the player remote script, we need to add a class name to reference it later in other scripts. Let's also add a function to update this node from a player data event by setting its position to that of the received event. Now back in the sync player's remote script, let's create a reference to the packed scene for the remote player node, as well as 2 helper functions for the spawning and destroying of the remote player node. Make sure to assign this packed scene in the inspector. So click on sync player remote and select the previously created remote player scene. Now onto the function for creating or updating a player. In In the create or update player method, we need to either get the player from our dictionary or instantiate a new one if it's a new connection. Then we can call the update from event function on the remote script and update the dictionary with the player instance. Secondly, in the delete function, we look for the player node in the dictionary and destroy it by calling the queue_free method on it. Finally, in the handle player events function, we need to use our newly defined methods. One thing we need to be careful of is that we don't update our local player with remote data. To check if a player is the local player, we need a reference to our local player node. Define an export variable with the player local type and assign it in the editor. Now at the beginning of the create or update player function, as well as the delete player function, we need to check that the player ID is not our local player ID. Because our local player ID is an integer, we need to parse it to a string first before we can compare it. Also add this check to the delete player method. Another thing we need to consider is that we now spawn all our players at the same position. Instead, we should spawn our local player at a random position. So here in our player local script, we can add a random spawn function to the ready function of the node. I defined a constant spawn radius and then generate x and y coordinates randomly in the range of minus spawn radius to plus spawn radius. Another thing I want to do is make sure that our local player is always at the center of our screen. We can achieve this by adding a camera 2D node to our player local as a child. I'm also zooming out the camera a bit to get a wider view of our scene. Another thing we should do is set the motion mode of our character body 2D to floating. That way it won't have any weird interactions with other players. Now if we run multiple instances of our game, we can see that we can control our local player and that it is synced to all other game instances. And when you close the windows, the players disconnect. One small thing we can add is the color of the players. So let's first color our local player. To change the color of our player sprite, we need access to the sprite node. We can either export a sprite variable to get the reference to that sprite, or we can make the sprite a unique children of the player local node. Either way works fine. I'm going to show you the second method here. If you right click on the sprite 2D, you can click here on access as unique name. This will add this percentage sign next to the sprite 2D. I'm also going to rename this to player sprite for more clarity. Now in our player script, we can directly access that sprite by specifying the percentage sign and the node name. We can change the modulate property to set the color. Accessing this player sprite node as a unique name has the advantage that even if we move it in our player tree, for example, if it becomes a children of another node, we still retain the reference. Now if you run the game, you will see that in each game instance, only the local player is colored in. So we also need to change the color of the remote players. We can do this in a similar way by opening the player remote scene. Let's also rename the sprite and access it as a unique name. Now in the update from event function in our player remote script, we can also update the color from the event. Now all the other players also have the correct color. Final touch we can add is to show the name of each of the players above them. Let's first start with the local player. Add a label to the player local node. Now place the label above the player. In the inspector, we can set the horizontal alignment to center and the vertical alignment to center as well. To change the font size, you would normally create a theme and create a global font size. However, for now, I'm just going to use the theme overrides to set a custom font size. I'm going to rename this node to player label and also make it unique. Now in the player local script, we can also set the text of our label to be the player name. Make sure to cast the player ID to string, otherwise you can't set the text property. Now let's also add this to the remote player. I'm going to copy this player label over to the player remote scene. And here in the player remote script, we can also set the player name. Now we can see the player ID of all players. One small thing you notice is that the text moves behind the other players. So let's quickly fix that as well. In the property of the label, I'm just going to set the set index to 1. That way, the label will always be drawn above the player sprites, as the sprites have a set index of 0. Also, don't forget to change the set index of the player label in the local player. Now that's it for this tutorial. I hope you've enjoyed this series so far. If you did, consider leaving a like and subscribing to my channel. In the next episode, we will work on improving the graphics a bit and make it look pretty. Stay tuned until then. As always, thank you so much for watching, and I'll see you in the next one. Take care.